Welcome back to this Introduction to PostGIS series. In this video, I'd like to cover the Python library GeoAlchemy and the concept of object relational mapping. The term object relational mapping is kind of an intimidating one, or at least it's pretty dense, but once it's broken down, it makes a lot of sense. It provides a mapping between a Python object or class that you, the developer, get to define, and the relational database you're pointing at. What this means is that when you query the database, rather than getting raw data back, you get a Python object with whatever additional functionality you've defined. We'll dive into this a little more with a couple examples, because this is a pretty awesome concept. It also means you get to query the database using Python functions rather than using SQL syntax. This kind of means you no longer have to know SQL to get data out of the database, but to be honest, the functions are set up really similarly to the way SQL is written, so you can't actually skate by without knowing at least some SQL. The other upside is because there's an abstraction layer between your code and the database. If you swap database types, say Oracle to Postgres, you no longer have to update your queries with any database-specific query syntax. SQLAchemy is a Python library that provides the Object Relational Mapping, or ORM, capability for Python. GeoAlchemy is an add-on to it that provides the functionality required to define and query spatial data. Today we'll cover how to define a new table and Python object using GeoAlchemy. We'll fill the table with data and run some spatial queries. We'll also cover creating a Python object for an existing table and do a query or two between the two tables. We'll stick with the flight radar data, but I'll start by dropping my airports table so we can recreate it using GeoAlchemy. All right, so we'll start by creating the engine that creates the connection between our code and PostGIS. This is the same engine that we use when we do connection with GeoPandas as well. So there's a few things that we have to import from SQLAchemy as well as GeoAlchemy. So we have to import this geometry definition from GeoAlchemy, and then a few things from SQLAchemy so that we can define our column types. And we'll start using these in a second, so that'll make a little bit more sense. So there's a little bit of code overhead before we can start going. We need to get a few things from SQLAchemy. We need to create a declarative base, which is sort of a base class that all of our functions will be built off of. And we need to create a session. And the session is going to act as sort of an intermediary between our code and the database. It's going to stage the data, and it's going to execute the queries for us. This is done in two stages. You have to call the session maker, and then create the session. We bind the session maker to the engine we declared above, and then create the actual session object that we're going to use. Okay, so now we can start creating our airports class. And so this any class that you declare that's going to be a SQLAchemy based class has to inherit from the base that we declared above. We can give it the table name. So we'll make it the same table that we had before. And so the data that we're going to be working with is the CSV of airports around the world. And these are the columns. And so we're going to need to tell SQLAchemy how to treat each column. So for each one of these, we have to let them know that this is a column of some type. So for the ID column, It's really helpful for SQLAchemy to have a primary key, so we can just add one. And if it's primary key, we'll just say integer, and primary key equals true. For most of these are string columns. So when you define the column, you tell SQLAchemy what type it is. The Latin longs are floats. These are all things that we imported from SQLAchemy. Altitude is actually an integer, but I'm going to leave it as a string because then we can show some additional functionality built in, like casting on the fly. And now this is where GeoAlchemy comes in. We can define a geometry column. So give it a name, and it's a column. And now we say that it's geometry, which we imported up here. We give it the type as a string. And then there's a few things that you don't have to add, but make your life just a whole lot better if you do. Specifying a projection. And this is inside the geometry function, not the column function. And then you can tell it to create a spatial index. And if you don't do this, you'll have to do it either manually or with code later on. But I find it's better to just let GeoAlchemy do it. Okay, so if we already had a table, this would pretty much be all we have to do. But we do need to have a way to create these from data coming in. And because this is a class, we can create an initialization function. And so because our data is coming from CSV, I'm going to use the CSV reader and create an instance of each airport from a CSV row. So that'll be coming in as a dictionary. And it doesn't seem intuitive because these don't have a self in front of them, but all of these are now variables that you can call from self as part of this class. So I'm just going to copy all of these. Bring them into our initialization function. Toss a self in front of them. All right, so this one's not fully accurate, so I'll get rid of this. Our name is coming in as a dictionary from the CSV. This should all work. The Latin long, we'll have to cast to a float. And then the geometry. So we actually need to import two things. We need the point class from Shapely. And from GeoAlchemy, we need the ability to go from Shapely shapes to their sort of internal representation. So we needed their toShape and FromShape functions. All right, so this geometry column is going to be FromShape. So we're taking a Shapely shape and making it into the GeoAlchemy version. We're going to create a new point of our x and y and give it a projection. Because we defined the projection up here, this part might not be totally critical, but it certainly doesn't hurt. Okay, so I think we can leave this here. We might want to make one more function just to get a shape out of this once we've got the object. Call it get point. And we'll go the other direction. We'll use the toShape to go to a Shapely shape from the self dot. Okay. So I'm going to go ahead and run this, and we can now create the table. using our engine. So that's what this call is. Because it's inherited stuff from base, we've got this table.create and engine. So now if we pop back over to pgadmin and refresh, we've got our airports table, which has an index. And there is one thing that I want to point out here under views and geometry columns. If we scroll down, there's a little bit of information that PostGIS uses to store about the spatial information for each of our tables. So in our flight and airports table, it knows what the geometry column is, and then what the projection is and the point. So because we spent the time to define the projection here, that actually is reflected in that table. So that allows us to do transforms and all that. Right, so now that we've got our table defined, we can actually start creating these objects. So I'm going to import the CSV library. We'll just do this sort of in more raw Python rather than using pandas. We have that airports.csv. Create the dictionary reader. Right, so we can loop over those rows in the standard CSV way. So for every row in our airports reader, we can create a new instance of that airport class using the init function that we defined. So each one of these rows is going to have all these values. And so this will be just an instance of the class. Now to add it to our session, which is how we're actually going to commit the data, we can just call session.add. And so this sort of stages it. If we actually want to flush the session and send it into PostGIS, we can do session.commit at the end. Now this is a pretty small file. So calling commit on all the rows once we're done reading is a-okay. If this was larger, you might want to put some sort of check, every 10 or 20,000 rows, call this commit so you're not trying to flush it all at once at the end. Right. Moment of truth, give that a run. And we can check back in here. So we open up tables, view the first 100 rows. We've got our table back, and we've got all of our airports mapped. Right, so that's creating the tables, but how do we get data back out? So the current way using SQLAchemy, and they're slowly changing the syntax with their version 2 that's coming out sometime, but you can use session.query, and then you tell it what you want to query. So in this case, if we just want to query the whole airport object, like that's what we want to get back, then we can filter. And you can use really just Python syntax, comparison syntax in here. So if we wanted, a lat greater than something or a long greater than something or a specific country, or if we knew the airport code, we could use that. But we can just filter by country. And we get this ORM query back. So we haven't actually gotten data back. We haven't actually gone out to PostGIS to get the response. So you can start getting this data back in a couple of ways. The first is just first. That'll just return you the first instance of this airport. Or if you want just everything, you can use .all, and it will give you a list of those. So we can call that US airports. Now we can treat it like a list. Grab the first one and get their name. Well, so the Aberdeen Regional Airport. So now, using this session query and Python filtering syntax with some specific functions that are built into SQLAchemy, we're able to get instances of this class that we've defined with this additional functionality. And to sort of drive this home a little bit more, I think it would be useful to add some additional functions here. So ways for Python to get us a little bit more information based on the information that it's already got. So I do want to add two functions, but the first is just going to be getting the current weather at that airport. And this might not be the best way to do it, but I'm going to use just for a proof of concept, the weather.gov API. So I'll make a function get current weather. And the URL is this, and you pass it a Latin long and a self.long. And we can use requests for this, so I'll have to import that. And then actually call request on that URL. And what this gives us back is not the actual weather, but based on that lat long, it tells you what region that's in, and it gives you a URL to query for the actual weather. If we get no response back or a poor response, return none. Otherwise, we can make another request call. And it gives that URL in the properties and forecast. And what we get back here is the actual forecast. And if we do the first period, that'll be the actual weather. Okay, so I think the details of this aren't too important, but I think the important part is that knowing a little bit of information like a lat long, the airport class itself can maybe get us this information back. And one thing to note is GeoAlchemy and SQLAchemy really don't like you to redeclare the same class over and over again, so this makes it sort of not a great thing for developing in Jupyter. I think there's a way around it, but the easiest way is to just sort of restart the kernel, redefine a few things, no big deal. So we'll redefine this. We no longer have to create it. We no longer have to import it. But now when we query this, for the first one, we can do the get current weather. Cool. And so now this gives us, the weather at this current time period. So maybe for the first like 10 airports or so, we can print out the wind speed and the airport name. So yeah, just the first 10. Get the weather. And then if that actually returns something, get the wind speed. All right, so we run this. It'll take a second to do each query, but it sort of gives us the semi-live information about the wind speed at these airports. So I think this is pretty cool. And I will say there's nothing that we've done here that you couldn't do in GeoPandas. You could make a new column with the wind speed, but if you do something like a web API, having these as object relational maps is pretty awesome, and it makes your internal code just super clean. Being able to say airport.getCurrentWeather is, I don't know, I think it's just really neat. Okay, so pretty much all we've displayed so far is object relational mapping. We haven't really done anything with geoalchemy. So one thing we could do is maybe given a specific coordinate, find all the airports within like some number of kilometers there. So what I want to do is define a point for, let's say, Lakeland, Florida. Which is roughly at negative 81.971, 28.04. Okay, so this is in decimal degrees. And we can use some functions inside of GeoAlchemy to buffer this out into a polygon and then run an intersection with our airports. And of course, if this was in a different projection, and maybe actually we could even project both and do that, you could do distance rather than intersects. Really, however you prefer and whatever you find to be fastest. But the first thing we can do is sort of buffer this out. And so we could certainly do this using Shapely and GeoPandas, but we can also use GeoAlchemy. And that'll actually create the SQL call to do this, so it'll make it PostGIS's problem rather than our problem. So like I said before, we've got to convert this point that's a shapely shape into something that GeoAlchemy can understand. So we can use the from shape, give it that point, and really important here is giving it a projection. We can use the st transform function. So you'll see that this function closely mirrors what you would expect in PostGIS, but now it's a Python function. Give it the projection, buffer it. So you can use st buffer as you would expect. And this is in meters now, so let's say 45 kilometers. And then send it back to 4326. All right, so I did this outside of an actual query because this is kind of long, and it shows that you can save this off. So now we can query the airports. So like above, session.query airport, and this is going to give us everything back from airport. If we just wanted the names, I think you can just do .name. Filter. Specify the geometry column, intersects, and call out our Lakeland, Florida point, and then get all. So when you start specifying what you actually want back rather than the object, it starts putting them in little tuples. So rather than do that, let's just get the actual objects, because there might be some more information that we want out of that. But if we just loop over that and print out the names, save the result of that off, and now that should work. All right, so now that we've defined a class for our airports, we've used that to insert data into PostGIS. We're going to kind of go the other direction. So we've already got our flights table in here. And so creating an object relational map for that in Python. The process is pretty similar. I mean, you don't need the init function. I did go ahead and create a primary key for this, which it didn't have before. I think you can get away without doing that and just kind of fudge it, but it never hurts to have a primary key anyways. All right, so first thing we need to do, just like before, is define our class and pass it that base object so it can inherit stuff from that. Specify the table name. And then we need to define all of our columns. And rather than force you to watch me type them all out, I'm just going to copy and paste from an existing one and highlight a couple things. We've got our primary key. If you don't have one, I think you can just add this here, and I think it just kind of gets ignored in the table, or maybe not filled. We've got our string columns, we've got our integer columns, we've got our geometry column, and here we should specify the SRID. Because we're not creating the table, I don't believe there's any penalty for not doing this, and we no longer need to tell it to create a spatial index. Right, so now we can actually just go ahead and query this table. So we can call our session.queryFlight. And just grab the first one. And we're getting information out after only having defined this and done one query. So that's pretty cool. So now we can maybe start doing more complicated queries between the two tables that we've got. We've got a flights table, we've got our airports table. We had done a query in the last video where we tried to identify all flights that were flying over an airport rather than landing at it. And so what we had to do was buffer the airport point by 2,000 meters, so kind of make a circle around the airport. Cast the altitude of that airport as an integer, and then run an intersection and make sure that the altitude of the airplane is greater than the altitude of the airport itself plus like another 40,000 feet. So we can actually do that exact same query here. And it does get a little complicated, but I think we can do it without too much fuss. So there's kind of two parts to it. So I think we can break this out into two parts. So we've got our airport geometry. We can call that st transform again. Buffer it. And send it back to 4326. Right, so that'll be our airport buffer. And then we can create a result on querying the flight. So we're expecting to get information about the flight class back. And then we want to use that st intersects. So there's actually a couple ways to call that. I've been using .st transforms on this, but there's a few other ways to actually query Geoalchemy. It certainly couldn't hurt to show those off here. So we'll want function from SQLAchemy. I'm also going to want to import the cast function so we can cast that altitude to an integer. Right, so we're querying flight. We can call .filter. And we can either do flight.geometry.st-intersects or use this func. And this one's a little bit more in line with the PostGIS way to do this, which is passing both geometries in. So pass in flight.geometry and the airport query we made above. And we can add another filter. And the way that SQLAchemy works is by basically daisy chaining these filters together. So in this one, we want the flight.altitude to be greater than the cast of airport altitude, cast to an integer, plus 40,000. And this is getting a little bit long, but then we just typed the .all to get all of the results. And if we did that right, that'll take a second to run. But then we can get the length of that result. And as I recall, that's the exact same number of points that we got back last time. Now that we've got this flights class here, there's one last thing that I want to do to sort of show off, stuff that you can do inside of SQLAchemy. So I'm going to scroll back up and maybe add one more function here called getDestinationsList. And so now that we've got the flights class, we can actually query that inside of here. And because each flight has a destination and source, we can kind of build out like a network graph or something. We're not going to do that here, but we are going to get a list of all of the distinct flights or places that this airport flies to. So we can kind of build out that query. And we just want the destination back. Then we want to filter by our origin airport. I'll use filter by here rather than filter, which will let us just not define the class. We can just say and then we just want distinct. So we don't want a whole, list of every option, but we do want just the unique ones, which is as easy as calling this distinct function .all. Like we saw before, that gives us back a list of tuples because we're getting the destination airport. And I tested this earlier, and some of these, even if you start somewhere, you don't have to file where you're going, so some of those are none. So what we can do is return and then do a list comprehension. Get the actual airport IATA itself. So loop over this list that we just got returned if it's not null. Okay. So I think that's all we need to do. So I'm going to restart this. Run a few things to declare our classes again. We don't need to fill it. We do need to declare this. All right, so let's run this US airports one again. All right, we print out the name of this airport, and then we can also call that getDestinationList function. It'll take a second to run, but now we get the codes for all the airports that, in theory, this airport flies to. And you can certainly build this out into something like a network graph or go from there. So in this video, we've covered what object relational mapping is, how to create a Python object based on a SQL table equivalent, added some functionality to that class, performed standard SQLAchemy queries as well as performing some spatial queries. As usual, a link to this code will be in the comments. We didn't touch on all of the spatial queries that GeoAlchemy provides, but I'll provide a link to that as well. It's pretty extensive from things like st-simplify to st-covers to st-as-geojson. It really covers the majority of the PostGIS capabilities. If this video brought up any questions or if you felt something wasn't totally clear, please feel free to ask them in the comments. If you found this content useful, I'd certainly appreciate a like, and if you'd like to see more content like this, please consider subscribing.